Welcome back. So we're still on chapter 7, energy changes, and today we're going to be looking at batteries. We're going to compare rechargeable and non-rechargeable batteries. You can find this sheet in your file. I want you to think about what we were doing last lesson. We were talking about how we can use two metals to create a voltage or to generate electricity. If we had two different metals in an electrolyte solution, that was a solution that contained ions that allowed a current to flow, electricity would be generated. Do you remember what was the rule about the two metals? Where would the electrons flow from? They would go from the most reactive. So we talked about how electrons would flow from the most reactive metal. Okay? And that basic idea of using metals to generate electricity has been used in batteries. I've got two batteries there. One that you might see in your TV remote control on the left, and one inside your mobile phone. Obviously two very different types of batteries. If we could look inside these batteries, we would not see two pieces of metals stuck into an electrolyte solution with a wire connected. But the basic idea is the same. In this battery or cell, simply, there would be chemicals that are reacting and they're going to generate electricity. So inside a battery or a chemical cell, we're having chemicals that can react and make electricity. So it's building on what we said last week. We showed how you can do it with two metals, but we can get other chemicals to react to generate electricity. So we're going to compare rechargeable and non-rechargeable batteries. If we say, first of all, what happens in a chemical cell then? Chemicals react to produce electricity. Chemicals react to produce electricity. Now a battery then, you may know this from your physics lessons, a battery is a series of connected cells. Okay? So inside a cell, we're going to have chemicals that are reacting to produce electricity. Now the two main types of batteries, and I apologise if sometimes I'm linking and jumping between the words cell and battery, but think of them as the same thing. Think of the cell and the battery as the same thing. We can have rechargeable and non-rechargeable. Now, in a cell, we're going to have chemicals that react and they're going to generate electricity. Now, like in any reaction, if the chemicals are reacting, they're getting used up. At some point, in a non-rechargeable battery, if the chemicals are getting used up, what's going to happen? Well, it's going to stop making electricity, because what will have happened to the reactant chemicals at the start? They will have been used up, and once they get used up, the reaction is finished and it will not generate electricity anymore. So we could say the battery is dead. So in a non-rechargeable battery, the chemical reaction stops when one reactant is used up. Okay? And we'd say at that point, the battery is dead. What we can't do to that reaction is reverse it. So the reaction that was happening inside the battery is non-reversible. The reaction is finished. One of the reactants or all of the reactants have been used up and the reaction is non-reversible. That is the end of the battery's life. An example would be the alkaline batteries. So the batteries we would tend to use in our TV remote control. You put them in, they might last a few months. Eventually, the chemicals inside the battery, one of them is going to get used up and it will not produce electricity anymore. However, think about the batteries in our phones or our iPads. The same basic principle is happening. There are chemicals inside the battery that are reacting. And if we leave them to react, they will generate electricity, but eventually one of the reactants will have been used up and it will stop producing electricity. What happens to your phone or your iPad if you eventually? Well, it will run out of power. It will stop, the battery will stop generating electricity because one of the reactants has been used up. But what can we then do? What does we plug in the battery? What do you think that's doing to the reaction? What do you think that is going to do to the reaction that generated the electricity? What it's going to do, it is going to reverse it. It reverses the reaction that happened inside the battery. Imagine it driving all the electrons back the other way, and therefore we're remaking those original chemicals as well that are going to react. So, and once we've remade them, the reaction can happen again and it will start to generate electricity. So what we're doing there, we're going to reverse the reaction that happens in the battery. So the reaction itself is reversible. How do we reverse it? How do we reverse the reaction in the battery? We have to plug it in. So a rechargeable cell or battery, it can be recharged by supplying an external current. That's just a way of saying we can plug it in. If we plug it in, we're going to recharge the battery. How are we recharging it? What are we doing to the reaction? We are reversing the reaction. So the reaction inside the battery is reversible. Okay? An example would be what we call lithium batteries in phones or in iPads. So fundamental difference. When we have a rechargeable battery, the reaction inside it is reversible. How do we reverse it? By supplying an external current, or you could say by plugging it in. One other quick thing at the bottom, because I did mention alkaline batteries. So the batteries in your TV remote control, they contain chemicals that react. Why do you think they're called alkaline batteries? What must there be inside that battery? Well, there's chemicals that are reacting. There's an electrolyte, a solution that the reaction is taking place in, and that electrolyte must be an alkali. The electrolyte inside the battery is an alkali. What does that mean it contains? If it is an alkaline solution, what must there be in the battery? Well done if you remembered. It contains hydroxide or OH minus ions. So alkaline batteries contain hydroxide or OH minus ions in the electrolyte. So just to summarise, we have talked about what happens in a cell, in a chemical cell or a battery. Chemicals are reacting to produce electricity. In a non-rechargeable battery, when the chemical reaction stops, the reaction is finished and one of the reactants has been used up, and that reaction cannot be reversed. But in a rechargeable battery, the reaction is reversible. The chemical reaction that produces electricity is reversible. How do we reverse it? By supplying an external current, by plugging it in. So there's two fundamental differences between the two types of battery. And the main difference is going to be the reaction that's happening inside that battery. One is reversible, one is not reversible. Hope that makes sense. Any questions, get in contact with your teacher, and I'll speak to you soon about another aspect of cells and batteries. Thank you very much.